Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland. And this short video, another video in our series now of videos dealing with mathematical induction, is going to look at a particular proof, another example of a proof by induction, where we have a particular series. Actually, this question I've actually taken from O.D. Morris's textbook, which is Text and Test 6 for Higher Level Leaving Cert. Yeah, and actually the question is asking something like this. It's saying prove for all n, an element of the natural numbers, prove that 3 plus 3 squared plus 3 cubed plus all the way through to plus 3 to the n. We want to prove that that's actually equal to 3 halves of 3 to the n minus 1. Okay, so we'd like to prove this particular statement. Okay, so don't forget the three-step process. Step 1 is where, well, I'll just write it up here. Step 1 is we prove true for a specific value. In this case, for all natural numbers, so we need to start off for n is equal to 1. Step 2 is we assume true for all values up to a specific value, n is equal to k. And 3, we show or we prove true for n is equal to the next one, which is k plus 1. Okay, the next term in the sequence, if that makes sense. Yeah, okay, or the next term in the series. Yeah, so let's show that this is actually true for n is equal to 1. So we want to show that this thing here, which is the sum of all the powers of 3 up to n, show that that's equal to 3 halves times 3 to the power of n minus 1. So we want to prove true for n is equal to 1. In other words, for the first, we want to show that this is true for the first thing in this particular series. Yeah. So when n is equal to 1, we actually simply have the left-hand side. The left-hand side is equal to 3. Okay. So the left-hand side is 3. What about the right-hand side? Well, the right-hand side is going to be 3 over 2 times 3 to the power, well, n is equal to 1, 3 to the power 1 minus 1, which is the same as 3 over 2 times, well, 3 to the power 1 is 3, minus 1 gives us 2, which is the same as equal to 3. So clearly we have the left-hand side is equal to the right-hand side, okay, when n is equal to 1. So when n is equal to 1, this thing here is actually equal to this thing here. Okay? And we've shown that to be true. So that's brilliant. We've got the first step done. So now we need to assume, this is going to be important for us, we're going to assume that for n is equal to k, so the sum of all the powers of 3 up to this specific value, assume that it's true for n is equal to k. In other words, what we're assuming to be true is that 3 plus 3 squared plus 3 cubed plus all the way through plus 3 up to the power of k is equal to 3 over 2 times 3 to the power of k minus 1. So this is what we're assuming to be true. Okay? And what we now want to do is we're going to prove true. We're going to prove true for n is equal to k plus 1. Okay? So it's well, here it is. So what we'd like to now prove true is we need to show that this particular series up to the k plus 1th term, okay, is equal to something over here up to the k plus 1. So what we'd like to show is this, is that 3 plus 3 squared plus 3 cubed plus all the way through to plus 3 to the k, okay, all the way through to the k plus 1, yeah, okay, to the k plus 1. We'd like to show that that's actually equal to 3 over 2, sorry, 3 to the k plus 1, okay, is equal to 3 over 2 times 3 to the power of k plus 1 minus 1. We'd like to show that this is actually true. So let's try this. So this is what we need to really get to. I just want to grab another pen here. Is that we need to show that this is actually true. Okay, knowing that this thing here is assumed to be true. So let's take this thing here and let's try to create this thing here from it. Okay. So let's see what we get on here. How we get on here. So let's take what we've assumed to be true. So let's consider, okay, what we assumed true. So what we've assumed true is that 3 plus 3 squared plus 3 cubed plus all the way through to 3 to the power of k is equal to 3 halves times 3 to the power of k minus 1. We've assumed